Hi, this is Dr. Behruz Fallahi. I'm with the Department of Mechanical Engineering at Northern Illinois University. This video is on derivation of the equations needed for position analysis of the inverted slider crank mechanism type 1. Let's first see what is inverted slider crank mechanism type 1. The figure here is a schematic diagram of this linkage. It consists of a crank, the dark blue link over here. The light blue is the output link with a slot inside, and then there is a block which can slide inside the slot, and the block is also pinned to the crank. For position analysis of the inverted slider crank mechanism, the length and the angle of the crank designated by vector R2 should be given. The location of the fixed pivot, second fixed pivot relative to the fixed pivot should be given. That implies that the values for R1 and theta 1 should be known to us. Once we have these four values, then we can solve for the length and the angle of vector R3. You should think that the length of vector R3 locates the block within the output link, and angle theta 3 orients or give us the angle of the output link, which is the light blue link here. For this course, when we start to set up the equation for position analysis, we always look for a set of vectors that forms a loop. For the slider crank, you can see that vectors R1, R2, and R3 forms a loop. In order to write the vector loop equation, you should think that you are traveling along the loop. If you go in the direction of a vector, write plus sign. If you go opposite direction of the vector, write minus sign until all the vectors in the loop has been traced. So I'm moving along R2, so here I have R2. I'm moving against R3 here, so I have minus R3. I'm moving against R1 to get where I started, so here I have minus R3. Now, if I look at this vector loop equation, vector R2 and R1 are known, vector R3 is unknown. So the solution procedure would be first to solve for the unknown vector. So I'm going to get the equation that I have written here. Next, what I'm going to do is to write the x and the y component of vector R3. The x component is simply the algebraic sum of the x component of vector R2 and vector R1, and that equation is shown as equation 1 in this slide. Similarly, I can write the y component. That's equation number 2. Since the right-hand side of equation 1 and equation 2 are known, what I can do is compute their values, and then I can compute the length of vector R3 based on their x and y component. That's described by equation 3, and I can compute the angle of the vector R3, and that is equation number 4. Now, here I have listed the equations that are needed in order to compute the values of R3 and theta 3, starting with the given values, which are R2, R1, theta 2, and theta 1. This completes this video. The next video that I would like you to watch is the MATCAD implementation of these equations for performing the position analysis of the inverted slider crank mechanism type 1.